Okay, on these I'm going to use a graphing calculator and synthetic division to find all of the zeros of these polynomial functions. Okay, so what I'm going to do here, because I haven't been given any other information, I could use rational zeros theorem. Oh, my granddaughter's gotten hold of this. So let me just clear that out. Okay, that's better now. All right, so let's put this in here. X to the fourth minus 8x cubed plus x squared plus 2x minus 80. Okay, so let me try and get the glare. The glare isn't so bad. And I'm just going to start with a zoom 6. Okay, so it looks like I have some X-intercepts there. And so what I might do, try and get better pictures, I might play with this window and see if I can get a better. All right, definitely -2. And then 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I have x-intercepts at -2 and +8. Just to make sure, I'm going to press second and graph. And come back down here to -2. All right, so you can see -2, 0 is on the graph. So I definitely have an x-intercept at -2. So -2 is a 0. So we get that from the graph. And then it also looked like 8 was a x-intercept. And I'll just make sure. The quickest way here is, yeah, because the point 8, 0 is on the graph. So x-intercepts yield real zeros, so I know that those are 2 zeros. So I can use this to break this down. It has degree 4. There'll be exactly 4 zeros. If I have any repeated zeros, I count them the number of times they're repeated, and that'll give me, when you're using that rule, to see how many zeros you have. Okay, so I'm going to do synthetic division. I think I'll do it with a positive one first. So I'm just going to set that up for synthetic division. And I'm going to get it started. So 1 times 8 is 8, and then we add, and 0 times 8 is 0, and then we add. 1 times 8 is 8, and then we add, and then 10 times 8 is 80, and then we add. And this is what I expected. I expected to have a remainder of 0 because 8 is a 0. And so these are the coefficients for my quotient. So that's my constant, that's my coefficient for x, x squared, and x cubed. So I can write f of x now as the divisor, which is x minus the 0, or x minus the number in the box, times the quotient. And the quotient is going to be 1 times x cubed plus 0 times x squared plus x plus 10. Okay. All right. And I'm not quite done. Now I'm going to use synthetic division to break this one down, and I'm going to use -2. So let's see what happens. So when I use synthetic division on this one, I'm going to put -2 in the box, and then I'm going to have this coefficient 1. There's no x squared term, which means its coefficient is 0. Don't forget to put the 0 placement in there. So to get the ball rolling, 1 times -2 is -2. Then we add. -2 times -2 is +4, and then we add. And 5 times -2 is -10, and then we add. And of course, the remainder is 0, which is what we expected. And so again, now I can break this one down. And so x cubed plus x plus 10 is going to be equal to the divisor, x minus -2, times the quotient. So there's my constant, my coefficient for x, my coefficient for x squared. So after all of that, I can now write f of x as x minus 8 And then instead of this, I have times x plus 2 times x squared minus 2x plus 5. And my pen is dying. Let me get another one. Okay. Now this, I'm going to need to use the quadratic formula to find out what the zeros are. So the zeros, because that doesn't factor easily at all just by looking at it, it doesn't. I can't find two numbers to multiply together to give me 5 and at the same time add up together to give me -2. So when it's in this form, I can see 8 is a 0, -2 is a 0, and I'm going to get the other two zeros by using quadratic formula on this. So a is 1, b is -2, and c is 5. And so the other zeros are going to be -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So it's going to give me 2 plus or minus 4 minus 20, which will be -16. And the square root of -16 is 4i. And then with cancellation, I'm going to have 1 plus 2i, plus or minus 2i. So my zeros, there's 4 of them. They're 8, -2, 1 plus 2i, and 1 minus 2i. Those are my 4 zeros. So it has degree 4, and there will be 4 distinct zeros. Okay. Now, what about this one? Always look to see if you have anything in common first that you can factor out. And we actually do on this one. This one, each term has an x in common, so I can factor it out. This does have degree 5, so there will be 5 zeros if I count repeated ones the number of times they're repeated, if that is the case. Okay, so straight away I can see that 0 is a 0. Because if I replace x with 0, the whole thing will be equal to 0. So 0 is a 0. Okay, we know that much. Well, then I just need to find the zeros of that. So let's look at that in the calculator. So I'm going to come here and I'm going to clear that out. I might actually come here and just have that be a 1. Okay, because that way it'll go by quicker. All right, so let's just put this one in. X to the 4th minus x cubed minus 16x squared plus 22x plus 24. And let's just have a look on a Zoom 6 and see what it's like. Okay. All right. It's kind of not too clear. It kind of looks like I have a 0 at -4. So we might want to all right, I have a 0 at 3 because I have an x-intercept at 3. So 3, 0 is an x-intercept. Okay, I think there's something more going on there, but anyway. And I think -4 is 1. Let me check that. Yeah. Now, I don't think that, don't really know if that's touching and bouncing back at +3. I just want to, might change the window. I think there's something else going on there. So what's going on at 3? Okay, so, and again, I might just, let's see what's going on at 3. Okay, so no, it's not touching and bouncing back at 3. It's actually, I've got another one here, so it's probably an irrational one there. And then it's coming up through 3. So it looks like I'm going to have 4 distinct X-intercepts, which will mean 4 real zeros, but I can see that 2 of them are integers, which are nice, 3, 0 and negative 4, 0. So these are the ones that are easy to see. There's actually there's actually 4 distinct ones, but negative 4 and 3 are the easy ones to see. All right, so I'm going to work on breaking this one down. Okay, so I'm going to use synthetic division, and I'll use the positive one. So I'm going to use synthetic division on this one. So I'm going to have 1, negative 1, negative 16, 22, and 24. We add, and we add, and we add, and then we add, and we get 0, which is what we expected. And so this polynomial is going to be the divisor, x minus 3, times the quotient. And that's going to be the constant x, x squared, and x cubed. Okay. And so I've used that one, and what I'll do next is I'll try synthetic division on this one using negative 4. And then we'll put it all together, because I want to break this one down. Okay. So we add. So the way I got started, 1 times negative 4 is negative 4. Then we add. And now negative 2 times negative 4 is positive 8. Then we add. And negative 2 times negative 4 is positive 8. And then we add. Again, that's what we expected. And so this is my quotient. So I'm going to have x and x squared. Okay, so this one that's underlined can be written as x minus negative 4 times the quotient. Okay, so where are we in all of this? We've got all these bits and pieces. Well, first we wrote, first we had g of x was equal to that. Then we wrote it where we factored out the x. Okay. Then I was able to break this one down, and I got it to where it was this. Okay. And then the next thing we did was to break that one down. So I'm just copying that from before, and this one turned out to be this right here. Okay, now I can't factor that by looking at it. I can't find 2 integers that multiply together to give me negative 2, but at the same time add up to give me negative 2. So I'm going to have to use a quadratic formula to get the zeros of this one. But g of x originally had degree 5. There's going to be 5 zeros, and we can see 0 is one of them, 3 is a 0, and negative 4 is a 0. So I got that one from factoring. I've got those from looking at the graphing calculator. And now I'm going to get these other zeros from using quadratic formula. So a is equal to 1, b is equal to -2, and c is equal to -2. And so my zeros, my remaining zeros, are going to be equal to -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay. So this is going to give me +4 plus or minus, okay, I'm going to have 4 plus 8, it looks like. All right, so +4 plus 8, which is going to give me the square root of 12. And the square root of 12, 12 is not a perfect square, but I'm going to write it as the square root of 4 times the square root of 3. Okay. So now I can split this up. And the square root of 4 is 2. And so that goes away. And, oh, that's going to be a +2. Not bad. 2. Okay, so let's write that again. So I'm going to have 2 over 2 plus the square root of 4, which is 2. And so I'm going to have 1 plus or minus the square root of 3. Okay, so after all of this, my 5 zeros are 0, 3, -4, 1 plus the square root of 3, and 1 minus the square root of 3. Okay, and that should do it for these two examples.